Hey, Stives here with Beard Logic, and this is episode 7 in the series where we build an adventure game. Today we'll finally be getting into the wall grab mechanics. So the plan is to get the character to jump, grab onto a ledge, and then be able to pull itself up. So let's get started. The first thing I'm going to do is get the wall set up to an appropriate height so that you can easily jump and grab it. Ideally we want to get it to the point where the character can grab any wall, but for the purposes of testing we just want to set it up so it's nice and easy to iterate over. Alright, let's go back into the code, and we're going to start in the player controller class. Since the wall grab is going to be a new animation state, we need to add a new value to the enumerator. And because it's so easy for me to forget, we're going to add this value to the switch statement right away. If you've been following the series up to this point, you probably already know what's going on here. I've got to add a couple more functions, one to determine when to go into the new state, and one to determine what to do once we're in it. By this point, I imagine you're pretty familiar with this paradigm, so I'm not going to go into too much detail. In addition to this, we're going to need another state for when we're climbing up from the wall hang. And we're just going to go ahead and add that value for that and all the function stubs as well. As an interesting side note here, there is a better way to do this where you don't have to keep adding stuff to the switch statement over and over. I have a plan to use scriptable objects to make this a lot easier to add new states and to transition between whatever states you want. If anyone is interested in that, let me know, because it's kind of a cool optimization, and I'll have a look at doing that after I'm done the videos for this series. Okay, so now we can start filling in our state machine conditions. Once you're in the wall hang state, I want the player to be able to climb up by using the jump button, so we're going to watch for that cue there. As a reminder here, I'm just going through and checking to see if the state conditions are met, and if it's not, then we return false. These functions will also push our system into the new state if the conditions are met. So for our wall hang statement, we definitely want to be against the wall, so we can add that as a condition right now. But we're going to need another condition to differentiate this from a simple wall slide. And what we're going to do for that is to check to see if there's a cliff above the player. So just like the is against wall value, we're going to add a new check that checks to see if there's a cliff above us. We're going to be updating this once a frame, just like the is against wall value. In fact, let's add a new call right where is against wall is being updated as well, and then we'll just have to write that function. So I'm just going to go to where that is against wall function was, and we're going to add the new function right there. And a good reason to do that is because the functions are going to be pretty similar. We're going to use a raycast as well for this, but instead of having the raycast from the player forward, we're going to be casting the ray from a position in front of and above the player directly downward. The trick here is picking the right start height. If the ray starts too high, it could detect a cliff that's way above the player, which we don't want. And if the ray starts too low, you won't detect a cliff until the player is practically above it. And so because of that, let's add a parameter so we can tweak it while the game is running. Additionally, we're going to add a distance value so we can tweak how far the ray is going to be cast. This is also important, but I would argue not quite as important as knowing where the ray is starting. We're going to be specifying the offset to the start of the ray as a local position relative to the character. Effectively, that means the Z value is in front of the character, the Y value is above, and the X is to the right. We could do that manually, but Unity's got a nice function called transform point, so let's use that instead. So we use the player's transform to transform that local point into a world point. From there, it's a simple matter of setting up our raycast to check to see if we've hit anything. I've gone over this in a little more detail in the past episode, so I think we can probably just gloss over this here. Surprising how simple it is once it's all said and done. Just one more thing I want to add for our own sanity here. Let's draw a debug line in the editor so we know where that ray is being cast. And a minor optimization here for the debug line. We're going to make it change color when it hits a cliff. Alright, let's try it out. The first thing I'm going to do is set up this line in front of the player so that it looks reasonable. Remember, the top of this line is the start of the ray and the bottom is the end. For now, it doesn't have to be perfect, we just need something that we can test with. So on the upward jump here, you can see that it turns color, so our ray is working, but we got a weird behavior going on. The player seems to be turning when he's against the wall. This is a definite bug, and I can tell you right now that it's not a bug that we just added, so we're going to have to look at some of the previous code to fix this. Let me hunt this down, and I'll get back to you. Okay, after a ridiculous amount of time trying to debug this, I finally figured out that the physics system was pushing us in the wrong direction. So this is what we had before. We were using the velocity to determine our direction. What we want to do is change it to something like this, where we're taking the direction that we'd specified above and using that directly. And after making that change, this is what it looks like. With that all working, we can now start filling in the state system code. The wall hang state should be pretty simple. Basically, we just want to stay there unless the player does something. So we're just going to set our velocity to 0. To transition into the wall hang state, we should probably be in the wall slide state already. So while in the wall slide state, let's add a check to see if we can enter the wall hang state. And when the player's hanging on the wall, we could potentially climb up, so we're going to add a check for that too. And before we go testing this, I just remembered we hadn't finished the code in the check for the wall hang. We went through all the trouble of adding that function to check if there was a cliff above us, and then we never added this line in. So let's just do that really quickly right now. And I almost forgot, we need to add a call to set state as well. And then I think we can test it out. So by the look of it, we're entering the wall hang state, but we're not staying up where we're supposed to. So I think this is just a situation where we're not taking into account the gravity that's being applied to the rigid body. So while in the wall hang state, we're going to remove any velocity the rigid body has, and we're also going to disable the gravity that's being applied to it. Well, it's not quite as simple as I thought, I guess. I think there's a couple things going on here. I didn't re-add the gravity back in, but I don't think that's going to quite fix this either. If you recall, we're storing the vertical velocity from the rigid body and adding it back in every frame. This looks like we're going to want an option to completely get rid of that stored vertical velocity. So I need to turn that stored vertical velocity into a member variable so that it can be altered elsewhere in this class. And then we're just going to replace it here, and we're good. And when we need to reset it, all we have to do is set it to 0. So just re-enable gravity here. And as long as we're hanging on the wall, we don't want to store that vertical velocity, so we'll just set it to 0 as well. And that's a lot closer to what I was expecting. Now that we got the character hanging there, let's get him climbing up. So in order to determine how the character will climb, we need a destination in mind. So I added another member variable called climb_target. And I'm going to set this just after the character is transitioned into the wall climb state. So I could just cast another array here, but we're already checking to see if a cliff exists, so we could probably just pull that data from the function we did earlier. So to facilitate that, I've already added a raycast hit member variable, and we're just going to replace the hit info of this function with that new member variable. And now that we have that hit info as a member variable, we can just simply take from that the point that we need. So what I just did for the cliff hit info, I also did for the wall hit info. I added a member variable and replaced the hit info in the function with the member variable. I also added a wall climb direction member variable, which we're going to be using right now. So just as we stored the wall climb target, we're going to store the wall climb direction as well. Alright, so we can start our climb up function here. We're going to add yet another member variable, and this one's going to be our wall climb speed. And we're going to serialize this one because we're going to want to be able to change it in the editor. Alright, just one more function to do, and I think we have it. So this function's a little different because we're going to be more or less scripting how the player's going to move. And so animating this could be a little different as well, but I think it should turn out fairly well. We're going to start off by checking the difference between where the character is and where he wants to be. There's going to be a couple cases. The first case is if he needs to go upwards. The next case is non-vertical movement. This will be when you're at the top of the cliff and need to move the remaining distance to the target. And lastly, once you've reached your destination, we need to get out of this state. So let's handle the transition case first. So once the player has reached the target, we don't really need to stay in the state any longer, so we may as well just transition directly to the move state. Just like in the wall hang state, we probably are going to be disabling the rigid body gravity, so let's re-enable it here. And seeing as we're dealing with this right now, we may as well just disable it at the top as well. So remember, we had to request a jump to get into this function, so let's just make sure that that's been turned off as well. And that's pretty much it for that part of this function, so let's deal with the vertical movement. So in this state, we're going to be moving directly upwards. So we'll start with the player's current position, and I assign the target's Y value to that position, and that's where we want to head. Then using the wall climb speed that we just added, we're going to use a lerp to go from one position to the next. And we're going to do something similar for the non-vertical movement, except we're going to replace two values here. The vert target now becomes our climb target, and the diff.y becomes the remaining magnitude of the diff. If you have any questions about the math here or anything else in this video, just leave a comment below and I'll be happy to help you out. And testing it out one last time, we should have it. This movement may look a little awkward to you, but in order to get the capsule around the cliff, we need to do something like this. We can actually have the animation make up for this difference, so it shouldn't be much of an obstacle. And I think that very thing will be tackled next time. Thank you for taking an interest in this series. If you'd like to see more videos like this, let me know by liking, subscribing, sharing, or commenting on this video. Your feedback helps me to know whether these videos are useful and whether or not I should continue making them, so please let me know. Bye for now.